Well, welcome to our studio, and today we're going to start a series on a little bit of mathematics. The kind of mathematics that will just remind you that which you're going to be required to do during your mostly PPL as well, but also very definitely your commercial pilot license. Right, and the first one we're going to look at arithmetic. You can see there's at this stage I've got up to 9 different stages, and we're now looking at the first one. Here we're going to look at the rules for signs. In other words, we're talking here about the plus and the minus signs. The first thing says is that 2 consecutive minuses, a minus and a minus, makes a plus. All right, and as we go through, just remember right through that these are very simple rules, and once you've got them, there's no problem. But there's a few examples here. Here I have the plus 2 plus 4. Plus and plus makes a plus, so it's plus 6. No problem there. Plus 2 plus minus 4. A plus and a minus makes a minus. So it'll be plus 2 minus 4 gives you minus 2. Straightforward. Just a minus plus another minus, that will become a minus. So it's minus 2 is minus 4. And then the last one is the tricky one where it says minus 2 minus minus. And remember that minus and minus becomes a plus. So it's the same as to say minus 2 plus 2 equals 0. Okay, these are straightforward understandings of the different signs and the rules of the signs. Okay, let's look at a bit at the bottom here. Here I've got a 26 plus a minus 34 minus a minus 55 plus a minus 61 minus a 23. So let's just now for a second transpose them. This 26, no problem, it goes to that 26. Plus minus 34 stays then minus 34. Oh, here we have a plus. Well, it's a minus and a minus, so that must make a plus 55. And there you've got your plus 55. Okay, when I clear this up, now let's look at this one, minus 50. Now remember, a minus and a minus makes a plus, so there you will see it is transposed as plus 50. And now for the last one, a plus and a minus must make a minus, so it's minus 61. And finally, it is just a minus 23. So that is how you resolve the pluses and the minuses. Well, what you've seen here now is that when you get something that got pluses and minuses, keep it in your mind that you can rectify the signs and what you want to do with those signs. So we won't say minus 2 plus minus 2. We will normally say minus 2 equals minus 4. All right, so get used to that one. Multiplication. Well, here, exactly the same kind of thing. And you'll see that the principle is carried through with the signs pretty much the same. So let's have a look at the first one. A plus multiplied by a plus equals a plus. Meaning that if you've got plus 4 and plus 3, then you will get a normal plus 12. Normally, let's just say, normally when we say add 2 to 3, we don't say plus 2 to plus 3. But remember, as you get into the mathematics, the negative figures are going to start jumping out because subtracting is going to be in the same line. Multiplying with negatives, that's going to be part of the line. And that is why we're having a look at this one. Right, so a plus times a minus, well, gives a minus. A plus 3 times a minus 3, and that, can you see the rule is now pulled through constantly, gives us minus 9. But when we get a minus times a minus, we get a plus. Yeah, if we got a minus and a minus, it means it's a plus. Same story, same results. Minus 3 times minus 4 becomes 12, but plus. Right, here's a few other let's say contemplations that we must make, and to say, how do we write things? Because normally we write 2 times 3. But in mathematics, we won't say x is like that. Remember, we make a mathematical x like that. Now, sometimes it's difficult to type this kind of x, then you type that kind of x. So really just keep your mind open. Is that now an x, or is that a multiplication? Because very soon in algebra you will see that signs, numbers and letters, figures, everything will come into one. All right, so 2 times 3 can also be written as a 2.3. And this is where we sort of drive the line, because if I want to have it being 2.3, then I'll obviously write a 2.3. There's a problem though, and we'll get to that one a little bit later, and then we can make a rule on how we want to do stuff in the future. However, I promise you, just to look at it, you'll see what they mean. Do they mean a fraction, or do they mean division? Because this same could mean 2 divided by 3. I don't want to confuse the issue right now. Remember, we work in decimals, and normally our answers will be at least rounded off to the second decimal. All right. The period, now that's the point, that one, that is in there, that one, that is in the place of the x then. When figures and mathematical signs are multiplied, the period can be dropped. So 25 multiplied by y could just be 25y. Ooh. But you can see, if it was 25 and you wanted to multiply the two, then you had to put the period in between. Or the multiplication sign. But if your formula is full of x's, it becomes difficult, and then you've got to discern, when are we saying it's an x and when do we say it's a multiplication? Just a little thing to wake up here. Right, but to recap that one, remember it goes minus, and a minus makes a plus, even under the multiplication rules. Right, now we're going to divide. Let's see if this one sticks all together. It says here that a plus divided by a plus gives us a plus. Okay, so plus 9 divided by plus 3 is plus 3. We would normally just say 9 divided by 3 equals 3. Remember that if you get a figure and it says 25, by implication it's a positive or a plus 25. Okay? So if you get presented with any number, let's say 55, and it's got no negative in front of it, you can take it that that is a positive. But when you write it in a string, minus that, plus that, minus that, plus that, and an and. So if you want to plus something that's actually in the minus category, then you get to say plus bracket the minus. Okay? So what do they say? The minus divided by the minus, it gives a minus. Well, we just, plus 2 minus 2 is 0. So that was a little bit different. But here with when we do divisions, you'll see that 9 divided by minus 3 must give us a minus sign. Minus and a plus, same story, also minus. And here the minus and minus again makes a plus. So that again, straightforward. Now divisions can be, and I prefer this one, if you want to type in a straight line, it's better to write this kind of sign there as a division. So 9 divided by 3, instead of setting 9 divided by 3, just the forward slash. It just makes it a little bit easier to quickly write it, because as you know, to write it to look as if it is, well, to present it in a mathematical form, it's a little bit more difficult just to type the numbers in. Okay, we'll get 2 more difficult ones. Power and roots. Okay, now we must pay attention to this one. The power and the roots. When a number or a figure is multiplied by itself, so let's take 3 times 3. It's multiplied by itself. Then you don't have to write 9, because this is 3 to the power 1 and that is 3 to the power 1, because it's just only once. But now, if you multiply these two, and you just take 3 and carry it over, then you've got to take both of those, and those are 2. If that is a 1 and that is a 1, then that becomes a 2. Now let's see here. It is raised to the second power. If multiplied 3 times, then it's cubed, or raised to the third power. So have a look here. 4 times 4 is 4 squared. 4 times 4 times 4 is 4 cubed. All right, straightforward stuff. In the example, 4, and I know these are words, but they are the base power, the base power. So you can say raised to the power of 3, because sometimes we say that, and although the raised part is called the index, a lot of people will say 2 to the power of 2. So remember, the base power is 2, and it's elevated to the power of, but sometimes, or in the real terms, it's actually called the index. It's not exactly how we speak. So we would say 10 to the power of minus 10, or we would say 10 to the power of 16, or whatever the case may be. All right. Now, just look here when we go to now, and we take 4, pardon me, 4 times 4 equals 16. Now the first quantity, the same as the first quantity, I could have said 3 times 3 equals 9. I didn't have to say 3 square, but 3 square would have been the same, because it would mean 3 times 3, and 3 times 3 is 9. But if I want to work with very big figures, like to the power of 27, I'm not going to say 3 times 3 times 3 times 3 times 3 and work it out. What is it to the power of 27? Okay, so let's let's use it in the easy way. So they say the first quadrant is known as the root. Okay, so the base is the root of the second quantity. What's the second quantity? Of 16. Now they've changed the word again, and they say, hey, When we have 3 times 3 is 39, then this first one is the root. Okay, I'm sure I can work with that. So if I go for the square root of 16, then it must be the root. So let's see, where's the root? There, they said, is the root. So the square of 16 equals the first root. Aha. That sort of works out. Naturally the same when we start talking about Q, and then it's just written like that. Right, so these are the basic signs that you must lose. All easy on the scientific calculator, just practice the actions. This is the thing that gets me. If you want to be able to write navigation, aerodynamics, anything, flight planning, where you're going to need to do calculations, it could have trig questions in it well. Can you work your scientific calculator? Can you work your, what we call it, what your nav computer or your, used to be a sporty or whatever make it is, doesn't matter. But the point is, can you read that? Do you understand? Now these things are actually extremely easy to read and work out. But if you are not used to it and you're under pressure in the exam, then you might start scrambling the wrong stuff. And if you start scrambling the wrong stuff, well, then you're going to get not scrambled eggs, that I can tell you, but scrambled other nonsense in the figures. Index. All right, so let's just go back here. The index, we said, is when powers of the base are multiplied, the indices are added to obtain. They use this now. Remember, they said this is the root, 3 to the power of 3, but they call those the indices. Because they're not going to say, okay, the powers of that times that. But you can see when there's a times, they simply plus. This is quite important to understand, that when you work with the indices, if I say 2 to the power of 4 equals, I beg your pardon, let me get that, 2 to the power of 3 multiplied by 2 to the power of 5, I keep the root the same, so the root stays 2, and the indices now will become, and now it's an addition. You add them up. Okay. Now listen carefully. When dividing, the indices are simply subtracted from each other. Oh, but here is a little bit of a catch. And now I need you to listen carefully. Here you can see in the first example is the easy one. You've got the biggest figure on top divided by the smaller one. Oh, so that's easy. If I would work from this side and I'd say 3 to the power of 3 times 3 to the power of 4, so it's 3 plus 4, then it will just simply mean 7, which is the answer, divided by that 3 will give us the answer of the 4. In other words, it's a subtraction. This subtracts the bottom, top, and now I say it can't go into a negative. Now, at the level that we're working with, let's just stay away now from, let's call it to the power of a negative number, just for now, because we want to get the division sorted out. So now you must listen, I think, very carefully. you would, for instance, have power to 17 over a power to 18, how are you going to solve this? Because if you take 17 away from the top, then you get 4 to the power of 0. Now the answer always of anything to the power of 0, the answer equals 1. That's just the mathematical truth that we're working with. That's a mathematical fact. Do not fight this one. So you don't want to end up in a sum like that with a 1, because then it actually is doesn't serve your purpose. So be very careful to go to a 1. So we at least have to leave 1 at the top. I mean, there's 17, but we need 1. So we can only have 16 at the top. So on top, we still have 4 to the power of 1. But now there's only 16 different, and 18 minus 16 is 2. All right? So that just goes all about this rule. Good. Now, the scientific calculators have the function to create brackets. A plus B minus C x D and those brackets. So go and look at your calculators, because whenever you want to open a bracket, it's quite simple. We're working above the line. Bracket 1 plus 2 minus 3 plus 4 blah blah blah. Close the brackets, equals. Then it will work out what's in the bracket, divided by bracket 5 plus 4 minus 3 plus 4 bracket, enters, and it will give you the sum there. So the bracket function is actually quite a marvelous tool. So let's keep to that. All right, and that then will bring us actually to the end of arithmetic. So go and practice now. There's a couple of examples. Oh, and I know you're going to say to me, well, it's so easy. Now that you have said that, that may be true. I also had to practice before I say it. You have to practice it before you can apply it, and before you're going to have to need this in the examination. Until the next one.